Hello, I'm Yasir. Today I will try to solve the boundary value problem using the shooting method. Uh, because there exists some methods that only solve the initial value problem. Ranjekata solve only initial value problem. So I will apply the initial value solver in Matlab to solve the boundary value problem. And it can be only done using the shooting approach. It, it might be there is some other method for this kind of thing, but I will use the shooting approach to apply the uh, the solver for initial value problems to the bond to solve the boundary value problem. So I will use the MATLAB solver OD45. The OD45 solves initial value problem. So I will use that solver, and also I will use the MATLAB solver F0 to have a shooting method. So this problem was obtained from the flow over the wedge. It's a Falkner scan flow, Falkner scan flow, and it was reduced to the equation 19 with the boundary condition 22. And then using some method for this kind of problem, the equation 28 are obtained. In equation 28, you can see except because one initial condition is not given, h of 0. H of 0 is equal to some unknown parameter. The remaining initial condition are given. There are six equations in 28 and there are six initial conditions. One is assumed, and this initial condition will be found by using the boundary condition corresponding to in 22 f prime of infinity is equal to 1. So this is the boundary condition on the right hand point. So this boundary condition will be used in the shooting method to get the value of initial value to get the value of initial condition on small h. So the boundary condition will be used to find the value of initial condition h of 0. So first it is assumed with some parameter, and then there two solver will be applied. One is F0 for solving just equations. The other solver would be used to solve differential equation. One solver will be used for solving equation. The other solver will be used for solving differential equations. So now I have a 28. So I have to solve the differential equation appeared in 28. So I will start with the coding. So I will introduce here a function. I say it's a shooting method for boundary value. And then CLC here, and then I will also have the no, I will suppose that I assume that particular parameter is P. So P is unknown parameter, and I assume its value in initial guess as 0. Then I will use the solver of F0. F0 is a MATLAB solver that solve the equations. So here I will solve some function, and that function will be constructed in this way. So I will introduce a new function with the R, output R, and input X or input P. Sorry. And I will give these differential equation in form of function. So for function, I use f is equal to t is the independent variable and u would be the dependent variable, and equation are f prime is equal to 28. In 28, f prime equal to g. So u2 will represent g. U2 will represent G. And then small h. Small h will be represented with U3 because it's a double derivative. Single derivative is represented as U2 and double derivative is represented as U3. And then for the third equation, I will use the right hand side of this minus A FH minus A. F is represented as U1 and F prime is U2. F double prime is U3. So f is just u1. U1 multiplied by small h. Small h is u3. Then plus b into g square. Small g is u2. So it's u2 square minus 1 bracket close. And then the next value, capital G. Capital G would be u5 because u4 will be capital F. U4 will be capital F and u5 is a derivative of F prime, capital F. The derivative of capital F is G. So u5 represent capital G and u6 represent capital H. And now the sixth equation, which is minus a F, capital F, and capital F is u4. And then small h is u3, and then minus a, small f u1, and then capital H is u6, and then plus 2 capital B as it is the parameter, and then small g is u2, and then capital G is u5. So these were the differential equations. No, I will use t as the independent variable, v is the dependent variable, and I will use the ode45 solver, and I will use here f function, and then I will use, I give the domain from 0 to 7, suppose that, with 50 points, and then I give the initial condition. Suppose that f, the small f of 0 in 28, the small f of 0 is f not v. So I suppose this value is u, and then the next value is f0 u. So I again suppose this value as u, and the third h of 0 is not specified. So that will be represented with the parameter p. That has to be found using the shooting method. Next initial condition is capital F of 0 is equal to 0. So I will use 0, and then capital G I at 0 is 0. So I will use 0, and the last condition is capital H as 0 at it is I use 1 here. So these were the initial conditions, 6 initial condition in which one is not known, others are known. Know what I will do here. The boundary condition is given. I will use the boundary condition. I will use the boundary condition to find the value of initial condition. So the boundary condition is F in 22, the third one, third boundary condition in 22. F prime of infinity. Infinity is in numerical computation, infinity considered as some numerical value 10, 5, 10, 15, 20. So suppose at the last endpoint, last endpoint will be represented as, because it's a variable v, and variable v, it's a last endpoint. So that would be a length of t. Length of t is a last endpoint. And then because the boundary condition is given on the derivative, for derivative it is 2. It is f prime. So f prime is represented with index 2. So because it says f prime of infinity is equal to 1. Infinity means right side. So right side, that's why I use length of t. No, because f prime of infinity, so that's the first derivative. So that's why I use 2. 2 is used for derivative, and length of t is for infinity, and then I will use its residue. So its residue will be minimized. So, so that's a thing. And this thing should be R. So that's output. That's output. And the F0 solver will try to make it 0. It will try to make this R as 0. So F0, I give the function. This function is OD. So I give the function here, ODE, and with the initial guess P. So therefore that's 0. And then here if suppose that I have to get the graph. So the graph would be the graph of derivative, the f prime, the velocity. So here I end this thing. Now if I run this code, of A and B are not specified. Suppose that A is equal to 0.1, B is equal to also 0, B is 0.4. Now if I run this, so that's a graph. Actually, the solver did not converge. Yes, because solver did not converge, so I have to use some other initial guess. If I change the initial guess, so suppose that zero, if I use 0.1, P as 0.1, so I check this. What happens? No, no, it's not. Still, it's not the accurate solution. It's not converging. Suppose that I give these values 0.7 here. I have to see that it's working or not properly. So again, it's not working. I choose some small domain instead of large domain. If I choose some small domain, 0 to 5 suppose that, and then I see what gives. No, it's converging. No, it's converging. On the smaller domain, 0 to 5, and yes, and uh, to get the value of double derivative at the first point. So you can find that with one, three. Third mean double derivative and one yet and on initial guess. Because in MATLAB, zero cannot be used here. It cannot be written as V03. So MATLAB will give error of that. So MATLAB start with the one. So actually, if it is zero, actually it is zero, but in MATLAB it will start it at from one. So this one V1 mean it's at zero. The value of the double derivative. These three mean double derivative. So double derivative at zero. So that will give the value. The double derivative at zero. So you can also find its value. So what will be the value for this? And because this is the value at function. This is the value first prime, and this p should be the double derivative. The value yeah, that's the value of the double derivative. And I checked that the value. What is the value of double derivative? It gives 0 point, and then oh, it gives 0.74 7426. So if I 7 4, if I modify this initial guess, and now I will use little large domain, then I have to see what happens. Yeah, now it's converging on the large domain because I changed the initial guess. Now that initial guess is working properly on this domain. So that was the shooting method, and yeah, and I used two solver, the one for solving equation F0, the other is solver, the OD45 is used for solving differential equations. So here I use in spaces. Then, so instead of OD45, Ranjakata method of any order can be used. Here any scheme for differential equation can be used instead of OD45. So this is one of the shortcut way to get the solution. So using the shooting approach. So that was shooting method. In my upcoming video or videos, I will try to apply Ranjagata 4 or some other numerical method to solve this equation. Okay, I end this video here. I love this. Bye.